So a new formulation, Mirenact ET20, formulated with ethanol.
However, is probably just give a quick background and introduction to some of the rest of the team within CREME Global who've been working on this over the years, past and present. Zorn is our wizard of multimedia and design, has been working heavily with the team for a long time now, and his positive fingerprints are all over Glopack. So thanks to Zorn. From the software team, which is headed up by Zishan, Matt, Andy, and Fiorica, and Kashif really have been working heavily. Our sort of, I guess, research and development pipeline moves from actually developing tools, moving them to a test facility, and that's of course a cyclical. There's feedback there, and then finally pushing them out in production, and that team works along that chain. And it's there's a lot of work that goes in behind the scenes, and there are a bunch of people who've remained anonymous but actually crucial throughout the whole project. And we've also spoken today about some of the exposure assessments that were done. That team will be headed up by Sandrine. Mark is with John's team. He's the head of data modeling and statistics. And there's quite a bit of mathematics behind these models as well, and I list some of the past members as well who support this, especially Maeve and Noel. So the key objectives from our side of the Glopack project was to increase the TRL level of various packaging solutions, but ultimately to provide food producers with the ability to make decisions and understand alternative packaging solutions that would meet their needs. And so we've done that via, I guess, two main processes that John will talk through. One is Data Foundry, which is our data warehouse. It's a centralized repository of data that's collected and is structured and gathered and validated, and that's not an insignificant amount of work. And then from there, there's the expert models platform where we do the sort of the fun stuff, and you can then model that. You preferentially call on various data sets that can then be modeled and can be interrogated to give someone insights from that data itself. So a little bit about us. We are a scientific modeling and data analytics company. We do a lot of work in consumer safety, around food safety, but also in exposure to fragrances and chemicals as well, pesticides and so forth. We have various large multinationals and consultants and so forth who would use our models as they apply for maybe to launch a new product to the market. And actually on the other side of the fence, a lot of the regulators and safety authorities globally would also use our models to assess the safety implications of those applications as well. And so if I was just to quickly run through some of the relevant work packages, there were various other bits that we contributed to, and I don't want to downgrade them, but just to link in with the main focus of this talk, which is actually going to be John's part, the demonstration. I just wanted to call out the main work packages and deliverables around that. And so it's all around WP1. And three main deliverables, having that cloud-based data management and a model execution platform that I've just briefly summarized, getting those digital mock-ups of the DSS being actually just one of the tools. I would take it as nearly the first port of call screening tool. I'll talk briefly about that in a moment. And then bringing this DSS, this decision support system, and the other tools up to prototype stage. This I will glance over with no disrespect to it, but I think, John, you may touch on this a wee bit more as that I guess modular platform repository that preferentially calls on data to run models, give people insights, and at times give them foresight as well. So some of the tools that we are now hosting in this central repository, the first one here is what we call this Facet, and Facets it comes from an FP7 project actually. Facet standing for flavors, additives, food contact material exposure tool. I guess in short, it would output the concentration of a chemical in a food. Is probably the short summary. So that's one of the tools, and I will run through these fairly quickly just to give a quick summary. This next tool, MapOpt, is the evolution of this modified atmosphere and its impact on the potential pathogen growth within it. And there's a little screen grab of the steps you see here. Actually, I don't know, I changed my pointer here. You see there are these 5 steps that the tool will walk you through, and you answer a series of questions, and ultimately that would output a table for you to interrogate. The oxygen scavenger tool is outputting gas concentrations over time, especially when you have in situ oxygen scavenging materials included in the packaging. The antimicrobial, this again is understanding the kinetics of the release of that antimicrobial compound into the headspace, and the headspace here is, I guess, and we've seen a few packaging examples, especially in the last presentation there, it's everything within the packaging, not including the product, all the sort of the free space, the free volume. This DSS, the decision support system, as I said briefly early on, I would take it as actually the first port of call screening wizard, where it walks you through a series of queries, and these can be sustainability. These are sort of material properties, sustainability properties, processing. There's sort of a ranking tool to ultimately for manufacturer to say, this is the material I currently work with, and but these are some alternatives that could be useful for me. And so that's why I see it as that sort of first port of call, and then they can dig down maybe using the other tools. And this EcoScore actually is quite a complex wizard, I guess, in a way. Zoran has spent a lot of time trying to simplify this, trying to increase the user experience and decrease the data input. So around these 3 pillars of materials, functionality, and end of life, to assess the environmental impact of a food packaging option. And ultimately then it would also input into a front of package sustainability label. So a consumer can I guess make an informed decision around ultimately from their point of view, a perceived value in purchasing a sustainable pack over something else. Beyond Glopack, and so yeah, you saw the little TRL symbols as I went through, and so all of these have been pushed out into, as I said, into production environment. We don't believe they're at full commercialization, so full TRL yet, but that is what's needed. Ultimately, we're an SME, and our job is to sell and to make money, and so that would be our goal. The use of these tools, as I've said, that DSS in particular, is to make a decision, and so decisions need to be made with relevant data, up to date, and all-encompassing data sets. And so that's one thing that's required. We need to increase that and make sure it's up to date and valid, and that will increase accuracy. The models themselves work on increasing precision, but the two need to work hand in hand. And so for us, we would consider, and I think there were various options that were discussed, such as even a separate startup company. For us, we do a lot of licensing of our software tools around the world, and so this again would be another offering that we consider. And so we can do that on an individual company basis, a trade organization, or even to create or join a sustainable packaging group. And I think this goes to the very first talk of the day with Andras and Camden BRI, when he talked about beyond Glopack and future funding and even these other European collaboration platforms that exist. And so we'd be very keen to ensure that these don't end at TRL 7, that they're brought to full commercialization. And so with that, I may hand over to you, John, if that's okay.
Yeah, thanks, James, and hi, everybody. So the minor difficulty in that I'm going to need both hands for typing, so I can't really hold this, but let's see if we can prop it up here. Okay, is that probably not picking me up? Is that you're great? Thank you. Brilliant. Okay, good stuff. Let me share my screen. The recursion now as it goes. Thinking. Okay, otherwise. It's worse. This is the beauty of live software. But it's actually not the software, I think it's the computer. Getting I could do. Okay, let's just get this quick. Okay. So apologies, everybody, bit of a glitch there. Okay, so I don't know how well you can see the URL, but the address you need to connect to have a go with all of these tools is glopack.expertmodels.com. Simple as that. So Glopack will be easy to remember. It's .expertmodels.com. If you wanted to create, it's all this access, password protected access. If you wanted to make yourself an account, there's a link here, request access. You click on that, you get some instructions about how to do that. For today, I have some credentials for some test accounts. So if anyone wants to have a go, I can share those with them. They're more than welcome to have a go and try the models out. Okay, but for now, let's just log me in. And here's the first screen you see. So what you're looking at is a platform called Expert Models. So it's a framework that we've developed at CREME Global. So we found that as we were developing all these exposure models, that we were reinventing the wheel a lot of the time. So we're writing software to do the same task, like read a particular type of data, plot a particular type of graph. So we decided to stop doing that and put our efforts into this platform, Expert Models. So you can kind of think of what you're seeing as a kind of an operating system, and the models of the programs that run it. So I just want to spend a couple of minutes on it, because there's a couple of things that are useful to know. So up the top here on this banner, we have a models button. And if you click that, it shows you the models you have access to. And if you click any of those, it just gives you a brief overview of the model, what it does, something about the model inputs, and a reference to where the model was originally described. We go back to files. There's also, if you see this, so JO is J.O'Brien, your initiative will be different. If you click there, there's also a support center. And there's here Glopack model execution, and here's all the notes for all the different particular models. So all the things I'm about to tell you are actually written here. You don't really need me at all. You can just go read all about it. And they're all fairly straightforward to use, I think. Okay, back to the files. Yeah, the main page then is basically file management. So this here is a folder that I created. The black icon represents an output from a model, and the two greens are inputs. So there's the usual file management functionality you'd expect if you right-click. There's all the usual things, move, copy, rename, all that kind of stuff. The last thing then that's worth knowing about is over here on the left. So we see the My Data tab, that's where we are now. But there's also a Glopack data tab. So a lot of these models are only as good as the data that they have to work with. And in a couple of cases, that's actually quite limited. But you can go here to check that. One thing to point out, for example, is the oxygen scavengers. We'll come to that later on. So these are the 4 different scavengers that we have data on, and we have them for these temperatures. Now that's all we have, so it's only those combinations that particular model will work on. So I'll come back to that later, and you'll see what I mean. But this is the place to come to check, oh, what did John say about those? You just come to the Glopack data, and it's all written there, and you can see it. I think another example worth looking at is the food parameters. So again, there's only data on 7 different foods in here. So for the moment, that's all they will work with. But given more data, it's a trivial matter to add that. So that's it for the platform. Let's go and actually use some of these models. So we'll go back to our Files tab. And to run any of the models, you just go over here to the New button, and you say Run Model, and it gives you the list. And we'll start off with the facet migration model. And that all of them, it starts a wizard. So the first thing you see, it's asking for a name for the model. By default, it will use the name of the model and a time and date stamp, but you can put anything you like in. So Glopack, demo, whatever makes sense on the day, and then confirm. Now the facet model is very simple, and all it does is it models the migration of the material through packaging material or any material, and those can be layered, so they can be multiple layers. So you need to do some work beforehand, and you need to give it the thickness of the layers, partition coefficients. I'll show you the file in a minute, but I prepared one earlier. So we just have to say choose file, go to my data, and there it is, facet input file, select. And then all it needs then is a duration in seconds. So I don't know, let's say 20. And then that's all we need to do. We can run and away it goes. So you'll see here some spinning arrows. That means that it's thinking about it. It actually spends most of its time queuing it. So all of these run on Amazon Web Services. So it's spinning up an instance, it goes into a queue and it waits. The running time is very fast. It's actually the queuing and getting ready to run that takes up most of the time. We won't wait for it. I made a few previously that are ready here. So here's an example of what the facet output looks like. So the first thing you get is a report, or you had 3 layers that we put in here. And it's giving us some end concentrations here. And there's a graph cross section through all the layers. This is the concentration of your particular material. And a little bit further down, we have the same thing over time. So all the action happened very quickly, and then they were fairly constant in this case. The inputs tab doesn't work for the moment. That's true across all of our models, but that is intended to show you the inputs that you actually used. So one day that will appear and will work, but for the moment it does nothing. And then the last thing to show you is these are the numbers that the graphs were drawn on. Excuse me. So you have the possibility over here under file, if you wanted to download that into a CSV file or a spreadsheet, whatever it may be. Okay, that's the facet model. Let me quickly go back and show you. Before I ran the model, I should have shown you this. So this is the input file that it will use. This is what describes. So we have the 3 layers. We have their thickness, their density, their residue value, and so on across. And it's very easy to add your own to that. It works very much like a spreadsheet. I won't do that for now, though, because we don't need it. And then, as you saw, it's very easy to load up and include in the model. Okay, so that's the facet model. Then the next model is the mapopt. Run mapopt. So this is a bit more complex in that there's much more input. And as James was saying, what the model does is it presents a wizard to you. In this case, the wizard has 5 different steps, each of which requires different aspects of the input from the user. So the first thing it's asking about is the packaging geometry. So what's the general shape? So by default, cuboid is selected over here, but it can be anything of the 4 options: rectangular frustum, a cylinder, conical frustum. Let's stay with cuboid. Then the next thing is the dimensions. So as you select, you probably can't read the labels on that, but this is the depth. As you select a particular input here, it shows you with arrows what it understands by that term there. So let's say that's going to be 5 centimeters, and we go across. So now it's the width, the little arrow has changed. So let's say it's a proper cube, let's say it's 5 all the way. And then let's say, so now tray thickness is showing in the corner. So I don't know, 120. If I pick crazy values here, it's because I don't know very much about packaging, I'm afraid. I can only blame poor education. And then at the bottom, then we have film thickness. So let's say that's 60 microns, something like that. So that's all we need for this particular step. Then we move on to the materials. Is the tray insulated? Yes or no? Let's say yes. And then select the tray material. Again, at the Glopack data tab that I showed you, you can go and you can get a list of the materials that are available, and you can't add to it there, but you can add to it by contacting us. So there's a big long list of those, plenty of them. I don't know, let's say PET is a good one to pick. And then let's ask about the film material. I don't know, let's say cling film PVC. That's all we need to do at that stage. Then the next thing is the food. And as I mentioned, yes, so we just have these handful that it works with, but let's say beef. We've been talking a lot about beef today. And then we want to know about the geometry of the food inside the container. Now, the diagram here has nothing to do with the geometry diagram that we showed earlier. So that looks like it's some sort of a frustum, but it's really to illustrate how the food fills the packaging. So the first filling type means that it fills the entire volume, takes the shape of the packaging. Multiple spheres is something like falafels, you have pieces in there. And then the third, miscellaneous, that's intended to refer to something that's not really touching the sides, like a block sitting inside the packaging, or a pile, if you like, I suppose. And then it's the same thing. Then we have various, various inputs. So I don't know, let's say 100 grams. Let's say volume is 80. And then the headspace area might be, I might use 20 square centimeters, something like that. And then the thickness of the food could be 4 or 5 centimeters, something along those. And then are we going to allow gas solubilization in the food material? So let's stay with the default yes. And then we can move on to the storage. Then the first thing it's asking is how much O2, what's the partial pressure within the headspace? So I don't know, let's say 12%, and then CO2 might be, I don't know, 1%, something. And are we going to allow the volume within the headspace to vary as the gases evolve? So the default is yes, let's leave that alone. And then we can say the storage regime. So let's say we start off 2 days rather, at 5 degrees, then we can add another regime. And we can say, I don't know, 10 days at 4 degrees, whatever it may be. And we can add as many of those as we like. And then the last tab then is the advanced options. Do we want to consider pathogen growth in the food? Let's go for it and say yes. And again, we're restricted to the pathogens that the model knows about. So for the moment, that's Listeria and Pseudomonas. Let's go with Listeria. Is it located on the food surface or throughout the food mass? Let's say throughout the food mass. And that's it. That's the only input we need. And again, we just go run, and off it goes, and we will see again a spinning wheel up here. Meanwhile, the other facet one that we ran earlier is finished. You can see that spinning wheel for this one is gone. So we won't wait for it. I prepared one earlier in here. Now the inputs I'm sure were different, but this is kind of typically what you would get. So some kind of summary of what you ran, and then again some graphs. So this is the concentration of O2 in the headspace over time, and this is for CO2. So that's decreasing over 12.5 days, I guess is what we picked. Same thing then for nitrogen. Headspace volume, I guess we allowed that to vary, same as we just now. O2 concentration in the food, CO2 in the food. Oh, no, I guess nitrogen isn't soluble, huh? Yeah, so as before, then the inputs tab, at the moment there's nothing. Watch this space, that will eventually tell you exactly what your inputs were. And then the gas concentrations, that's the data that the graphs are built on. And again, should you want to dig into that some more, you can download that. You have the option over here in the corner. So that's that for MapOpt. I will jump back then to my data. There we go. And then the other type of model, then the next one I think is the O2 scavengers. So we'll use the default name. And again, this is going to be a very familiar pattern. You have a wizard, this time with 4 stages, a lot of the same elements. So what's the food type? Let's say falafels. So that's going to be multiple spheres. So depending which one of these you pick, you'll see that the inputs obviously change because that depends what they are. So for falafels, it's multiple spheres. So how many? Let's say a dozen, I don't know, 2 centimeters, something like that for diameter. And let's say it's, I don't know, 120 grams, something like that, and 110 volume. Let's leave the additional parameters alone, and we move on to the tray. And now we have the same thing. So what's the geometry? We've kind of seen that before. Let's pick the cylinder. Well, I guess no, falafels don't really come in cylinders, do they? So let's go with the rectangular frustum, and we'll stick in our dimensions here. It's really not much new here. Then the lower width, the lower length, and then the height, I don't know, that might be 5 as well. And again, tray thickness. And then again, the tray material, we've seen that also. We've got the insulation. So now what's the scavenger type within? So you remember before I showed you, this is the table I showed you in the Glopack data. So this is where that counts. So we only have data for these 3 scavengers. So not only are we restricted to that, but we also can only use the temperatures that were in that table. So I remember them for gallic acid, so I'm going to pick that. It's 5 and 10 degrees and 21, and another one that I don't remember, we won't use it. So we want a proportion then of the scavenger within it, let's say 5%. Let's leave out the gas solubilization, but the tray mass, I don't know, 40 grams, something like that. Seems a bit heavy, but it will work anyway. And then similar thing for the film, we just pick the material, go with PVC, cling film PVC again. And now our scavenger will pick gallic acid, which doesn't have to be, but we can pick the same one. And then the proportion in here is, let's say 3%, and the film thickness is 60 microns. I don't know what the sensible value is there. And the density, let's say, is 5 kilos per cubic meter. And again, for storage, then it's the same thing. Partial pressure of O2. 14% and 2%. And now this is the bit that matters for the storage. So the number of days, let's say 5 degrees. So we can only put the temperatures in that table that I showed you earlier. So 5 degrees is one of the temperatures that I've, just because we don't have the kinetic data that goes with that, that particular combination. But all these things can be added to. We won't bother with another regime. I think you've seen how that works. Oops, sorry. So then all we have to do, we've answered all the questions for the wizard. Just click run and off we go. Yeah, so once again, we're faster than the expert models is. So the previous one is finished, but this is still going. So I'll show you some typical output. So again, it's graphs of concentration of O2 here, CO2, N2, headspace volume changing, and it is the shine one. And then the same thing, you have the data underlying those graphs are all here and can be downloaded. Okay, then there's one more model here on EM to show you. So again, we go new. This is a well-trodden path now. Run model. So it's the antimicrobial model. It's called AITC. That just refers to one material, and I think really it's antimicrobial, so we'll be naming it in the future. So maybe I don't even need to run this. It's the very similar inputs. So we have the packaging here, the usual dimensions. You can change if need be. Then the food, very same thing. I won't bother filling it in. Then the tray. Now here, so we have no data at all for this model. Oh, sorry, I've got a white out. So we have no data at all. Am I in the right place? Storage. Yeah, here we are. Sorry. So we don't have any data for this model at all. So in the ordinary course of things, where we come to this active component, what it would actually ask for is, it would go off to the database, find what it knew about and present it to the list here, but we don't have any data at all for this. So what we've done is we put in a couple of built-in kind of notional ones, active component 1 and 2. So yeah, it's not really doing anything sensible, but it does show you how the model works, which is the point at the moment. And again, if we get data, it can be added into the database, and they would then appear here. So again, we have the same thing with film and with storage, all the same. What's new here is humidity is asked for here for a while, and we don't have a storage regime. So I won't run here. I will abandon this one because you're not seeing anything really new. But we can jump. Yeah, so this one says it's failed because I didn't really finish it off. But if I go to the results, you should see an example of the antimicrobial. And again, this is all kind of very familiar, I guess. You have concentrations for some of the antimicrobial over time, so up to 5 days, and then the same thing in the film. So this isn't the same run, but this reflects the inputs I used at the time. So AITC in the tray, AITC in the external atmosphere, and total AITC mass between the two. And again, it won't surprise anyone that this is where the data for all those plots are. And again, that can be downloaded. So those are the main models. So the next thing I'd like to show you is the decision support system. So that's here under this tab. That's a bit different from the models. It's doing something a little bit different. So if I click here, you get the Glopack DSS. So it's asking me for my passwords. I need to use the manager for that. And here we go. So I'm afraid that the font is really small in this. I think it's going to be impossible for anyone to see what's written up here. But just to tell you what's going on with this. So what this is the decision support system is based on a big table that lists, I think it's 440 different materials, along with all the various characteristics, so permeability, recyclability, things like that. And what this interface is, it's a means of filtering down through that, so that you can put in the attributes that you're interested in. And at the end, then the results tab will show you, well, these are the materials that match those criteria. So I think you're going to have to take this on faith. I doubt you can really see very much there. But the first input then is the permeability or permeance units. So according to what we pick, so if I pick, for example, grams per meter squared per day, that changes, it talks then about the permeance rather than permeability, and it just looks for a single value. So we can put in whatever we like into there. And we have a tolerance here, so we allow a certain tolerance. So if I say 50%, that means that it will return any permeance value that is within 50% above or below the value I've put in there. And the same thing we have for CO2 permeance here. I can put in any particular number, and again, that has its own particular tolerance at the bottom that goes with that. So it allows a bit of kind of vagueness in the search, if you like, I suppose. And then at the bottom, then we have a film thickness. I'll go back up here. So according to the units, so if I pick bar, then it goes back. If I pick bar instead, it goes back to permeability, and now it allows a minimum and a maximum. The very same kind of entry thing. And you also have a tolerance still associated with that. So that's by way of start. I realize I kind of skipped over something. So across the top here, just so you know what you're looking at, these are, again, they're tabs. They kind of correspond to the tabs in the wizard. They're different kind of thematic connections, really, of the variables that you're allowed to select. And you might be just about able to see there's 4 green boxes down here. They reflect what you've selected so far. So there's 3 of them are there because they have default values. So as soon as you start, there's something selected there. And the units one we've just selected. So you can actually revisit any of those, and you can click it and it will show you what it is that you picked. And as we add more criteria, that list grows. So the next tab across is the sustainability criteria. So we have things like the origin of the main packaging component. There's a drop-down menu with your various choices here. You'll notice that only one of them is white, all the others are grayed out. And the reason for that is that as you put a criteria in, it's already doing the filtering. So if it sees that, well, you actually ruled out so many criteria, you can't select this, that's why they're grayed out. So presumably the units selection, whatever we selected, will have eliminated most of those choices for the origin of the main packaging component. So other things, other criteria you can pick. There's biodegradability options. Again, we're only allowed one, which is non-biodegradable here, I see. Resource footprint score, there's a drop down for that as well. So medium, high, and low. And then there's the climate change score. So again, that would be medium, high, and low. Then there's processing criteria. So the process type for final application, again, a drop-down menu for which of those. So I don't know, it's hard to read even up here. Blow molding, injection molding, there's about 7 or 8 different ones, and you can select whatever you need. And the last one then is the other criteria. So that's commercial availability and transparency. So transparency is transparent, opaque, and translucent, and commercially available is just yes or no. Then there's a tab. Oh, by the way, I should say as well, all of these are optional. You don't have to select a criteria. You can ignore, you can put in 2 criteria, 1 criteria, whatever you need. The last kind of step, which again can be ignored, is kind of an overall tolerance level. And that's to do with how many blanks you're prepared to accept in your output. So the default is set for high tolerance, which will allow up to 50% of the fields in the output to be blank. We've got a medium and a low. The low insists that no more than 25% are blank. So that can filter out a lot of chaff. And then at the end, I don't know if we'll actually see anything here. I may have ruled out all the rows. Yeah, I guess I did. Excuse me, that's where the results. Oh no, yeah, no, I have. Yeah, I have. Excuse me. Yeah, so that's kind of it. There's a reset button. If you get something like that and you can't figure what it is that you've that's ruled everything out, you can reset and start over, or you can click back through the various options. It's always when you see a gray upper line like that, that means that actually everything has been ruled out. So those are good places to start, I guess. Okay, then the final thing I think to show you is the EcoScore tool. So I won't go very much into this. I feel I've tried your patience enough as it is.
Yeah, very briefly, if you would.
Yeah, sure. Yeah, okay. So yeah, back at the Glopack data tab, there's this is the EcoScore template. So what that is, it's just an Excel spreadsheet. We can't take the credit for it. University of Montpellier developed it and sent it on to us. So if we just go here to download, you can download it here, and then rather than wasting time with that, I have it open here. Oh, here, there it is. Yeah, so there's various inputs. It's quite lengthy to fill out completely, but all the orange boxes. So here you list the materials, their weight, their function, and then you have various inputs to describe the material, the percentage weight, and so on. Hide that. And then about the functionality and end of life. Yeah, it's quite a lot to fill out everything, so I won't even try. But again, like I say, anyone who wants to play around with these, I have some credentials for some demo accounts. So please let me know, and I can share those with you if you want to have a go yourself. So sorry that ran over.
That's wonderful. Thanks a lot. That's a lot. Thanks. Okay. Good.